Okay, so we need to find the volume of area bounded by these condition about the x equals -1. So let me draw that. This is actually, if you isolate the y, you get 1 over x. And that's a hyperbola. So let me draw a rough hyperbola. Okay, roughly looks like that. This is the y-axis, x-axis. Okay, so y is equal to 0 is the x-axis. So we're talking about, it's bounded by, first of all, this, okay, this. And we're bounded by x equals 1. So when x is equal to 1, y is equal to 1, that vertical line, x equals 2. Okay, this vertical line, and this is the area. We're going to rotate that about x equals -1, which is right here. Okay, so look, there's exactly 2 spaces apart. So here, it's exactly 2 spaces apart. So we gotta go to -2, -3. Okay. Okay, so the rotation will look like this. All right. I don't know if you guys can visualize that. Okay, so here's what we have to do. We have to get here, let me just illustrate this. We have to first of all get a function of this outer flat cylinder, okay, and subtract of the inner, okay, flat cylinder. Okay, so we need, let me zoom in a bit. Okay, so what we need an expression, okay, for, let me use green, for the radius of this green here. Okay, so let me call that R1. Okay, and we need an expression for the radius of the inside. Let me use pink, the inside smaller circle. Let me call that R2. Okay. Okay, so the next thing is we're actually integrating upwards, right? So the cylinder is going to be there. Both of these values are going to be x values, which is in return a function of y. So let me say these are function of y. Okay. Okay, so the radius, first of all, this first R1 length, right? So let's consider. You know what, let me erase some of this. I think there's too much going on here. I think it'll confuse you more if I draw more on top of it. Okay. Okay, do you actually see that, first of all, up to here, up to right there, it's actually a normal, it's just a normal cylinder. Okay, so if you rotate that flat, right, about the x equals -1, we're going to get just a plain cylinder, okay, like this. Okay, where the height is 1 and the radius is constant. It's constantly 1, 2, 3. Okay, it's 3. So that part right there, this part rotated, right, this part right here rotated, is just pi 3 squared times by 1. Okay, so what we actually need to find, okay, here through integration is this part, rotating just this part here. Okay, that part. Okay, that part, just rotating that part. Just this little blue part about x equals -1. Okay. All right, so this right here, when x is equal to 2, y is going to equal to half. Okay, so we're integrating from half to, and that right there is 1, 1. So half to 1. Okay. And what we're going to do is get an expression for this radius. Okay, from the center all the way to, okay, all the way to the function. Okay, that's, you can see that's going to be 1 plus this x length. Okay. So that's actually the radius one I was talking about here. It's 1 plus essentially x, where x is a function of y. So it's 1 over y because it's from this reciprocal function here. Okay. Alright, so half to 1, it's pi. So let me just go back to being black. Pi, right? 1 plus 1 over y. Okay, 1 plus 1 over y squared. That's the radius. Okay, dy. Okay. And I'm just going to subtract off this cylinder inside. So do you see this blue cylinder inside? Okay, this cylinder right here. That's just a cylinder with radius being exactly 2. Okay, so from here, right, from here to all the way to there, the length is exactly 2. The height is half. So the volume of this is pi 2 squared times by half, which is exactly 2 pi. So we just have to subtract 2 pi. And that's the top part. That's the top part of the volume. Okay, and all we have to do is add this, okay, which is the bottom part. So plus, okay, should I go back to being black? Plus this is pi 3 squared. Okay, so this is going to give us the volume. All right, so this half to 1. Let me zoom out now a bit. Pi, expand that, you get 1 plus 2 over y plus 1 over y squared. Okay, this is minus 2 pi plus 9 pi, so we can take care of that separately. Half 1, so the antiderivative of this inside is going to be y plus 2 ln of y minus 1 over y. Okay. So that's the antiderivative. So remember the 1 over y is from ln of y, and 1 over y squared is minus 1 over y squared, so that's why it's minus 1 over y here. That gives you 7 pi. Okay. Now we can just finally plug it in. 1. Ln of 1 is 0, so 0 minus 1. Okay. Minus, plug in half. Half plus 2 ln of half. Ln of half, and then if you plug in half in here, you're gonna get a minus 2. The reciprocal of half is 2. Okay, plus 7 pi. Alright, so that's gone. Right, so here we have a pi, right, a minus half, a minus 2 ln of half, okay, and a minus 2 at the end. This minus 2 is part of this, so it actually becomes plus 2. Okay. Alright, so pi 2 minus half is 3 over 2, and actually ln of half is by using log. This is the same as ln of 2 to the power of negative 1. That's minus ln of 2, so this is going to be plus 2 ln of 2. Okay, plus 7 pi. So I think that's as much as we can simplify. I mean, beyond this, you just need to punch it in the calculator. Okay. Actually, maybe we can add these two. Okay, if you expand that, you get 3 pi over 2. Okay, 3 pi over 2 plus 7 pi at the back. The 2 ln of 2 we cannot combine with anything. So this is 17 pi over 2 plus 2 ln of 2.